Welcome to Sunday afternoon, early evening. We have our 2.2 to 2.4 pre-assessment, working with solving for the variable when dealing with inequalities. Inequality signs, we need to remember a couple things. This is less than or equal to, this is greater than or equal to. And that's going to come into play when we have to graph our solutions. So we need to remember that these are open circles and these are going to be closed circles. We're going to include it because it's equal to. So when we have an inequality and something is being added and subtracted, we treat it very similar to an equation. We see 3 is subtracting it, so we're going to add 3 to both sides, leaving us with x is less than -1. Notice my variable comes first. We kind of look at that as my solutions or the solutions. The solutions are less than -1. So when graphing, I want you always to tell me where 0 is and then tell me where your solution is going to be. -1 is going to be to the left of 0. Now it's a less than sign, so we're going to have an open circle. And we're going to go, the solutions are less than, so values that are less than go to the left. And we want this graph to be above the number line. We don't want it to get in the way. We don't want it to create anything confusing or busy. We can see it's open. We can see that it's going to the left because it's above the graph. The numbers go below, the graphing goes above. Number 2, again, this time we have to get rid of a -3 by adding 3. And -3 and +3 makes 0 is greater than h. Now, this is where a lot of students will make mistakes. Be careful. Be careful. Something we need to notice the variable is on the right. So since the variable is on the right, we have 0 is greater than my solutions. Now, a lot of students might do this. Now you only need one number, and they might do an open and saying greater than because, oh, that's a greater than sign. So we're going to go to the right. Let's rewrite our variable first. Our inequality is eating the 0. So when I write my variable first and my 0, it's still eating the 0. And now we see my solutions are less than 0. So that graph is actually going to go to the left. When the variable is to the right, it can get confusing and you have to be careful. When we have double signs, we should always simplify before moving. So a negative and a negative makes a positive. And now what's happening to the variable? It's being added. So we're going to subtract 1. +1, -1, cancel, leaving you with s is greater than or equal to 1. We don't flip the inequality sign. Do not flip the inequality sign. Do not flip. Don't flip when you subtract 1, when there's a -1. That's not the time. So we'll do 0. We'll place where 1 is. This is an greater than or equal to, so we will close that circle, and values that are greater go to the right. Do not flip. We only flip when we multiply or divide both sides by a negative. That's not this case. Always simplify. Remember, key, simplify first before moving. Before isolating, we want to simplify. We have these like terms here on the same side. So 6 and -9 is -3 plus u is less than -2. Now we'll get rid of this -3 by adding 3, giving us u is less than 1. Let's graph it. Let's show the 0. Let's show where 1 is. Open circle, and my solutions are less than 1. Again, let's simplify. Here we have like terms on the same side. 12 is less than or equal to, 4c minus 3c is just c, plus 10. Let's get rid of that positive 10 by subtracting 10. 2 is less than or equal to c. Notice my variables on the right. I'm going to rewrite that, and it's eating the c, so let's make sure it's still eating the c. It's worthwhile. It's worthwhile. Worthwhile? I think that's how. To rewrite. It's worthwhile because it takes 2 seconds, and then we can ensure that we are graphing in the proper direction. It's going to be a closed circle because it's greater than or equal to 2, and then I go to the right. Ooh, lots of simplifying here. We've got 2 places where we can simplify. We've got like terms on this side, and we have like terms on that side. So 15, negative 7p, and 8p leaves me with positive p is greater than. 15 minus 2 is 13. We're going to get rid of this positive 15 by subtracting 15. The left side is p is greater than negative 2. That's my answer. 0. I'm going to graph my negative 2. Open circle. And it's greater than, so it's going to go to the right. Now, 2, 3, there is a little bit of a difference here. So when we have inequalities, we have to be very aware of when we multiply or divide both sides by a negative number. So we're still going to isolate what's happening to the variable is being multiplied by 6. The inverse of multiplying by 6 is dividing by 6. We divided both sides by positive 6. That does not make you flip the inequality because we divided both sides by a positive 6, so we'll graph it. We'll put 0, we'll put our negative 5, open circle, and my solutions are less than, so we'll go to the left here. Let's divide by 16, divide by 16. I don't know what 48 over 16, I don't know if 48 and 16 can simplify, or 16 goes into 48, so I'm just going to reduce it. I'm going to take half, which is 24, and 8, and now I see that it's 3 times, because 8 times 3. So notice that I took a little time to do a little scratch work. Just to ensure that I did this correctly. So we get 3 is less than or equal to f. We're going to rewrite it. We'll rewrite our flip them on the other side, and it was eating the f, so it'll still eat the f when I rewrite it. 3, it's going to be a closed circle, and my solutions are greater than. Oh, I like this one. So we have a fraction that is multiplying. We are not going to divide by that fraction. You could, but it's just way harder. We're going to multiply by the reciprocal. The reciprocal of 3/7 is 7/3. We'll multiply it by 7/3. And here's some nice. We're going to cross cancel. Numerator, denominator, denominator, numerator. And then we've got that negative in there. So negative 2 is less than or equal to f. We don't flip the inequality sign when we multiply both sides by a positive. Now, I will flip it because I'm rewriting with my variable, and I need it to eat the f. So we have 0, negative 2, closed circle, and greater than goes to the right. So here is our first dividing both sides by a negative. Notice, this is a key thing. Notice, we multiplied both sides by a negative. So we must flip the inequality sign. Now the reason behind that, and we can get into a little technical stuff, is we get, well, not x, we get Well, let's do this too. We got m is less than or equal to positive 4. A negative divided by a negative is a positive. But we divided both sides because, hey, the way we make something, when we change the sign of a variable, we have to move it across. That's the technique that we're using. Because, I'll show you. Negative 4m is greater than negative 16. Now, my issue is I've got a negative 4. If I add 4m to both sides, notice what happens. We get 0 is greater than 4m minus 16. So now it went from my solutions being greater than to my solutions being less than. And the reason is I turned it from negative to positive, and the way you do that is you move it across the inequality sign. And then we can add 16 to both sides. And we get 16 is greater than 4m. And then we divide by 4. And we get 4 is greater than m, or m is less than 4. And notice, or less than or equal to, whoops, I forgot all my equal to's, sorry. And so notice that when we moved it, it became. So that's the tricky part. That's the sort of big idea here. You can just remember this, that whenever we multiply or we actually divided, multiplied or divided, multiply or divide, sorry. I was so eager to divide by a negative that I called it multiplied. Both sides. So we're going to graph it. We're going to 0. We'll do 4. We'll have a closed circle, and we're going to go to the left. So that is the most important thing whenever anything is multiplying or dividing. Both sides, we have to remember that. Here, it's being divided by negative 6. We're going to multiply by negative 6. We're going to multiply by, I'm sorry, my brain, late Sunday. We're going to multiply by negative 6. Because that's the inverse of dividing by negative 6. Leaving us with x, we must flip the inequality sign from greater than to less than. We can also cancel. 3 is in the denominator. Negative 6 is in the numerator. That gives me negative 2. And that's my solution. Let's keep up the blue work. So 0. We've got negative 2. That's a horrible 0. It looks like a 6. Notice I take the time to rewrite it. It is an open circle, and it is less than. We're going to multiply by the reciprocal. The reciprocal of negative 1/4 is negative 4. We'll multiply both sides by negative 4. Since I multiply both sides by a negative, I need to flip the inequality sign. And now my variable is on the right, so I'm going to rewrite with my variable on the left. If it's eating the negative 4, it still needs to eat the negative 4. 0, negative 4, close circle, because it's equal to, and my solutions are less than. We're going to not divide. We're going to multiply by the reciprocal again, negative 1/4. And we, again, have a numerator and a denominator that can cancel each other. Negative 1 times 1 is negative 1. 2 times 3 is 6. And then we have to remember all this stuff tends to make us forget. Oh, I forgot to flip because I was so concerned with the multiplication of fractions. Keep track. We multiply both sides by a negative. We must flip it from less than to greater than. And now we have another flipping because we're rewriting. That's a bad 6. Mr. Max struggling with the 6s today. Good, and it's eating the negative 1/6, so we'll keep it with that. 0, negative 1/6, open circle, going to the left, less than. We're going to multiply both sides by the reciprocal, which is negative 5/4. Negative 5/4. 4 in the denominator, 2 in the numerator. 1, 2 leaves us with x. We have to flip because we multiply both sides. And we have a negative times a negative, which is positive. You have 1 times 5 is 5 and over 2. So that is our answer. That's a little tricky one right there. 5 over 2, closed circle, going to the left, less than. So multi-step. Multi-step problems, we're going to have to, recognize some things. One of this, if we look at this problem, we notice it's a two-step. We notice there's only one variable, something's adding and something's multiplying. So at this stage, we should know that we're getting rid of addition and subtraction first, leaving us with 4a is greater than or equal to -8. Then we'll divide by 4. And our answer is a is greater than or equal to -2. We don't flip this inequality because we divided by a positive number. And now we'll graph 0, -2, closed circle because it's equal to, and greater than, so it's going to the right. Again, two-step equation. We're going to get rid of addition and subtraction first. This negative, let's remember something. Remember that -c over 2, let's put that negative where we want it to be. We want it right even, is the same as this, which is the same as this. So if I'm going to write -c over 2 and I want to isolate for the variable, it's best to have this one. Of the three, it's going to be better for me to write c over -2 is greater than -2. -8 plus 6 is -2. And now maybe you see why I wanted to put it there. So if I want to get c by itself, it's being divided by -2. I'm going to multiply by -2. C, I multiply both sides by a negative, so I flip my inequality. A -2 times -2 is +4. So you see that was really beneficial. C is less than 4, open circle going. So when we get situations like that, that's sort of an idea that'll help you. All right, so here's the real interesting one. Now we get a little bit more sophisticated. So we have to simplify first. One of the ways is simplifying first. And we can simplify by distributing. And we get 8 is less than or equal to -4d minus 4. Remember, when we distribute, that -4 has to be distributed to both terms, d and +1. -4 times d is -4d. -4 times 1 is -4. And now it's a two-step equation. So now we can add 4. 12 is less than or equal to -4d. Divide by -4. Remember, we're dividing both sides by a negative. So this becomes -3 is greater than. We have to flip the inequality sign. D. And now I always want to write my variable first, and it's pointing at the D, so I'm going to continue it to point at the D. We'll graph it 0, -3, closed circle, going to the left. That wasn't a great -3. Let's improve that. And I'm going to show you another way. I'm going to show you maybe a way that the high school students might do this, or some students at American Martyrs would do it. We could divide first, and that gives us -2 is greater than or equal to d plus 1. Because we divided both sides by -4, we need to flip it, and then we subtract 1, and we still get that same answer. -3 is greater than d, or d is less than or equal to -3. Same answer, same solution, just two different ways you might see it done. I'm going to use distribution again. 10.2 is greater than -3z minus 3. Let's add that 3 to both sides, giving me 113. giving me 13.2. 13.2. We're aligning ones place is greater than negative 3z. We'll divide by negative 3, divide by negative 3. I know that goes in, that's going to be negative, and that goes in 4 times 4.4. I'm going to remember to flip the inequality sign, even though I had lots of other things going on here. And we could see that 3 divided by 13.2. 3 doesn't go into 1. 3 goes into 13 4 times. Bring down the 1, 2. Bring up the decimal point. The decimal point always travels up. It never travels down. And then it goes in 4 times. So that's my scratch work. And we get this. I'm going to write my variable first. It's eating the variable, negative 4.4. Checking my work with my negatives. Yep, I flipped the inequality when I divided both sides. And when I divided a positive by a negative, it still got a negative. And so 0, negative 4.4, open circle, going to the right. All right, so here, there's nothing to simplify. We can't combine these. These are unlike terms. These are unlike terms. So I'm always going to move the variable first. As we go along this video, you should be writing key notes, key important factors. Anything that I write on the side is something that you should be paying attention to because it will be on the assessment. So let's move those variables first. We'll add 4n to both sides. 5 plus 2n is greater than 8. Now we're going to move this positive 5 by subtracting 5. 2n is greater than 3. Divide by 2. Divide by 2. N is greater than 3 halves. 0. 3 halves. Open. Going to the right. We'll move this. Move the variables first. Same thing, variable constant, variable constant. So let's get rid of the variables first. Minus 6h, minus 6h. And what do we notice here? Notice the variables canceled. The variables canceled. And they created a true statement and made, instead of writing created, made a true statement. So this is true. Negative 18 is less than 1. So my answer is infinitely many solutions. And how do I graph that? I just graph it by putting an arrow above it. You can put 0. I wouldn't mind that. That's not a bad thing. You don't have to, but you're just graphing above it. Okay? Every single number is a solution. How do we graph every single number? By doing an arrow, a line with an arrow above my graph. Still can't simplify, so let's move the variables first. 7p plus 4 is greater than or equal to 25. Let's move the constants. 7p is greater than or equal to 21. Divide by 7. P is greater than or equal to 3. That's a nice easy one. There was nothing tricky about that. Closed circle, going to the right. Here we go. So we need to simplify. Simplify first before isolating. So we have like terms here. No like terms on the other side. 7j minus 4j is 3j plus 6 is less than negative 2 plus 3j. Let's move the variables. Let's minus 3j minus 3j. Gives me 6 is less than negative 2. So notice, variables cancel. And it made a false statement. Six is not less than negative 2. That is false. So my answer is no solution. And since there is no number that's a solution, we don't graph anything on here. We leave it blank. And so you don't have a solution to graph because there is no number that works. So let's do this. Let's distribute. We have to simplify both sides. We'll distribute both numbers. 12 times 1/4 w for 12 gives me 3w. And then we take the 12 and multiply by 3, which is 36, is less than or equal to 3w minus 12. We'll move the variables. 36 is less than or equal to negative 12. That is also false. Let's go back and make sure. Yep, that's 3w. Yep, that's 3w. False. So again, we get no solution. You have to show this work. You can't get no solution. You only get no solution or infinitely many solutions when the variables cancel. We have to see the variables cancel, and it's the number statement, not the variable statement, that tells you that it's that type of answer. I saw some students write 6w is less than 6w or equal, whatever. You have to get rid of the variables. We have like terms here on the same side, and we have distribution that we have to do. What's that going to give us? That's going to give us 2x plus 5.8 is greater than, that's going to be 2x plus 3.6. Yes. Let's move the variables. Wow, we got a lot of canceling of variables. That leaves us with 5.8 is greater than 3.6. Variables cancel. Let's do. That's true statement. And so it is infinitely many solutions. And don't forget to graph. This is good, but you still need to graph. That's it. All right. You should be good to go. Also remember, one of the places that you can go if you want even more practice problems is you can go on to Big Ideas. Big Ideas. You can get in here. And remember, they've got the skills trainer. So skills trainer, if we go, you got to go to chapter, and we are chapter 2. And if you want to do so solving multi-step inequalities. So there's an infinite number of inequalities that we can do, and then you graph it, and then you check it. And that's really awesome. You can also do lots of steps, right? And then you can also do multiplication and division. So you have an infinite number of problems, especially with this assessment, that you can take advantage of. So I hope you do. Good luck. I'll see you.